No one has joined as of now. Okay, let's begin. So, good evening, everyone, and welcome to fifth live interaction session for this Matlab based programming lab in chemical engineering. Okay, so uh, a brief about me. So, I'm Bhavesh Moorjani. I have completed my graduation from MS University Baroda in chemical engineering. After that, I was working at Gujarat State Fertilizer for 1.5 years, and then I joined IIT Bombay as a PhD student. In my BTech, I was introduced to this Matlab course where we learned about the basics of Matlab and programming in Matlab. And then currently in my PhD work, I use Matlab programming to solve various problems. And for this course, which is Matlab based programming lab in chemical engineering, for this NPTEL course, I am currently your TA. So every week we meet for this live interaction session where we try to solve some problems and understand what what has been taught by professors in the previous week class, right? So these are my social sites. If you want to discuss any query related to MATLAB, you can contact me here. Else you can join me in this online class, and then we can discuss it out, right? Now, for this week 5 class, first let's go through what sir has taught it. Oh, I haven't shared my screen. So for the week 5, the main discussion was solution solution to the simultaneous system of equation, right? Where you have linear equations which are connected to each other. So you have multiple linear equations, and then how to solve them simultaneously, right? For that, what sir has taken an very nice example of multi-component distillation column from the refinery unit, where you have crude oil coming in, which goes to various distillation process, and then you have multiple products coming out. Of this example, we were given. I thought somebody joined. Okay, yeah. Mm. In this example, various feed composition has been various feed composition as well as the crude composition has been provided. So you had three different crudes, two Russian and so one Russian crude and one Middle Eastern crude, which composition was given, and the initial one Okay, right? So you have a feed composition for that, and you have product composition for all these streams also. Then what you have to do, you have to do a basic mass balance, and then find out what are the flow rates for each of these streams, right? So what you will land up with this will be a basic linear system of equations, something like this. So this is for one component. Once you do this for all component, you will get multiple number of equations that you have to solve simultaneously, right? So these are basic mass balance equations which you have to solve using linear algebra, and for that we relied on the inbuilt commands of the Matlab, which is line solve and then backslash division operator. We will learn about that also in the today's class, like how to solve this uh, system of equations, right? Simultaneous system of equations. What are the solution methods available? By what numerical method you can solve this, and what inbuilt command you have in the Matlab to solve that. Then after that there were some sensitivity analysis that was done by sir, and then some of the code part was not completely given, and you had been asked to do it by yourself. So what I will do, I will teach you I will teach you a question which is similar to in this line, and then we will discuss about this aspect also, like how to import various variables and how to use it. So this detect import option, then read table option, we will discuss that. And based on that, then you can if you haven't solved this problem yet, you can try and attempt to solve this problem. Okay, so that will be one aspect today. What else? Yeah, I think there were the sensitivity analysis. hmm. Okay, so since this problem is kind of expected to solve by you, I won't be discussing this whole problem unless any of you have a specific doubt. As of now no one has joined, but let's say, okay, so there is one person. Yeah, so I'm saying that since sir is expecting you to solve this problem on your own, so that's why I am not I am not solving this problem today, but we will be solving similar problems, and I will try to cover different aspects such as importing questions, and then importing variables, and converting equations into the matrices to solve this problem. Okay, so that should help you to do this entire problem on your own, right? So that will be today's goal. If you have if you still have any specific doubt related to this problem, do let me know, then we can think about to solving it separately, right? So coming to the concept of today's part. So first is what to do when we have a linear algebraic equations. We have multiple sets of linear algebraic equations, right? So when I say system of simultaneous equations or system of linear equations, so that is a set of equations. So let's say you have m equation with n unknown variables, which will look like something like this. So here you can see you have from x1 to xn you have n variables, and then you have m equations. So this thing is called this I am referring as system of linear equations, right? So when you are solving such system of equations, you cannot solve them individually, right? So since you have n variables, so I cannot select only one equation and try to solve it. I have to solve all the equations together simultaneously to find out the solution, what are the x1 to xn values, right? Provided that you know all the coefficients data from a11 to amn, and the corresponding b1 to bm data. Okay, now why this linear algebraic equations are important to us? So as a chemical engineer, when we do basic mass balance and energy balance operations for any process or unit operation, right? So you must have encountered multi-component system, in which if you have realized, what you are doing is nothing but you are solving linear equations. Since we generally when we are doing it through pen and paper, we consider one or two component examples, right? So that we can solve it easily through pen and paper. But when you have multi-component systems such as multi-component distillation, or let's say adsorption of multi-component gases, or a reaction with multiple components, right? So in such cases you might so you will come across, not might, you will come across multiple algebraic equations. Sometimes they might be non-linear, but if you are talking about mass balance in general, or energy balance, they are generally the basic problems are linear, right? So then you will end up with the linear algebraic equations. In the last two class, what we did was we solved non-linear equations, right? So we used fsolve, solve, VPA solve commands in the Matlab to find the solution of that non-linear algebraic equations. But right now we have this linear equations. So the solution of this will be this will differ slightly compared to that. Okay. So first we will try to understand how to solve this linear algebraic equations. What are the different methods, and then we will proceed with the example, right? So this system of equation here, I can represent it in terms of the matrix algebra, right? So you can represent it as Ax equal to b, where your A becomes coefficient matrix, which is m cross n. Here m is your number of equations, right, and n is number of unknowns. Okay, so correspondingly your variable matrix or vector will be n cross 1, and then your constant matrix is m cross 1. So when you simplify it, if you do Ax into b and then compare each row, you will end up with this previous equations, right? So this is a better representation of the system of equation into the linear algebra. Now from this equation itself, if you want to solve equation for x, then what will be your x value? That is A inverse into b, right? So if you do that, you should be able to get the solutions for your variables. Okay. Now if you recall your mathematical maths basic, or then you must realize that finding an inverse of a matrix is much difficult once you have a higher number of dimensions, right? And specifically in the computational part also, finding the inverse of matrix is considered hard. Okay, so in that case, you directly doing an inverse of matrix is not considered a good idea. Thus we have other numerical methods. What are these numerical methods? So these numerical methods are Gauss elimination, LU decomposition, and Jacobi iteration method. Okay, so before I come to that this method itself, let's first try to understand that how my solution will vary based on the conditions of this linear equations, right? So let's say I have been given this system of equation. Now how do I know that I will find the exact solution for this equation, whether that there does not exist any solution or there are infinitely possible solutions, right? So for that you must revisit this rank of matrix concept, right? So what is matrix rank? Rank is nothing but a maximum number of linearly independent row or column. Okay, so and this metric rank concept is important, particularly in finding the solution of your linear equations, right? So let's say we have this Ax equal to b system of equation. Now what we do is we find the rank of matrix A, and we find the rank of matrix A comma b, which is augmented matrix, right? So what you do, you add a column B at the end of a matrix A, and thus it is called as augmented matrix. You find the rank of both matrix A and augmented matrix, then you compare that. If both the matrix has the same rank, which is equal to number of unknowns or number of variables, then you will get a unique solution. Since you have what does this mean is that rank of matrix is equal to n. That means that all the equations are linearly independent, right? So what does my rank show? That rank shows that maximum number of linearly independent rows. That means all the equations are unique, so that different, they are not related. That means I should get a unique solution. If both the ranks are same but their value is less than n, that means my system is underdetermined. I have some linearly dependent equations, so I might have infinitely many solutions. Okay, then let's say if this both ranks are not equal, that means system is over determined. That means you have more equations than the unknown, right? So so your system, that's why your system is over determined. So you cannot solve this equations simultaneously in that case, right? So in that case you refer to different methods to solve your equation. So generally that is followed by a minimization of your problem. Okay, that is something separate concept. But right now for our purpose we have to focus on with this two part, that whether system has a unique solution or infinitely many solution or no solution. Okay, so this solving system with no solution using least square method is something different aspect. We might touch maybe later down the course or not, right? But so once you have been given the system of equations, you have to first understand whether you can solve the system or not by finding the rank of this matrix. So to find a rank of a matrix, you have inbuilt command option ready in Matlab, which is rank. Right? We have previously seen this in the introduction classes on how to find the rank of a matrix. So let's look at some of that examples on finding the rank of matrix and how to correlate it with the system of equation and determine whether we will have a unique solution, whether we will have a infinite solution. Okay, so if you will see, if you will type help rank, so rank provides the matrix rank. Okay, rank A provides the estimated number of linearly independent row or column of a given matrix. So let's consider I have a matrix and I find the rank. So it's a 2x2 matrix. So now if you recall, rank of a matrix, right? Rank of a matrix is minimum of its row or column, right? So if I have a, let's say I have a this 2x3 matrix, so rank of matrix will be minimum of these two. Okay, because you will look for the linear dependency in the either row or column part. Okay, so rank of matrix is minimum of either row or column. Okay, so here I have provided, so these two systems are linearly independent. But let's say I considered a row which is exactly double of the previous first row, right? So this is my row matrix A, and now when I find the rank of matrix A, you can see I'm getting 1 because the second row is nothing but the twice multiplication of the first row. Because of that you are getting rank of matrix as a 1. Okay, so that means that row 1 and 2 are linearly dependent on each other. How? That your row number 2 is equal to 2 times row number 1. Okay, so this is how linear relationship is defined, and you can find it through so if you have a matrix, you can compute its rank and then compare whether your matrix is linearly dependent or whether your rows in the matrices are linearly dependent or independent. Okay, now we want to check, let's see, if we have been given the system of equation, how to determine whether we have a unique solution or not. So let's consider some of this example. So we have to determine the rank of following matrices and comment on the solution to Ax equal to B system of equation, right? So first we have system A which has 1, 2 and 3, 4 as an element. So let's try it. A is equal to 1 comma 2 and then 3, 4, right? 3, 4. If I find a matrix rank of A, this is 2. Now and this just tells me about the rank of matrix. But if I want to see what will be my linear system of equation based on this matrix, I have not been provided the data of this vector B, right? So for as of now, let's consider it as a 0, 0 and then try to see what happens. So I want to find the augmented matrix A comma B first, right? So let me put B is equal to 0, 0. Why only two values? Since it's a 2 cross 2 matrix, So my row will correspond to number of equations and column will correspond to number of unknowns, right? So B matrix becomes number of unknown times 1. So this is my B matrix. My augmented matrix is combination of A, B, right? So you can do either A, B. This will, oh sorry, my B should be a column matrix, right? This is my B matrix, and this is how your A comma B look like. This is augmented matrix AB. So basically you are adding the third column, final column as your B matrix. Okay, you can also provide A comma B, that will also give you the same result. So let me define my matrix C as A comma B and find the rank of matrix C. So here rank of matrix C is also 2. So what we saw earlier, that if both the ranks are same and they are equal to n, which is your number of unknowns, number of variables, then you will have a unique solution, right? So if I try to find the solution with matrix A, so let's say I have 1 time x1 plus 2 times x2 is equal to 3 times x1 plus 4 times x2. If this is my system of equations, then I can find its solution by doing inverse of A into B, right? So this is actually 0 0. So that's a unique solution. The solution is 0 0 because if you will see there is no correlation, then only condition where it will be satisfied when will be when your x1 and x2 is 0, right? So that's a unique solution, still a unique solution, right? Then we have a second example. Your matrix A is 1 2 3 2 4 6 4 5 6. Matrix A equals 1 2 3 2 4 6, then 4 5 6, right? So this is my matrix A. Now here I can directly look at the row number 1 and 2 and see they are linearly dependent, since 2 times row 1 will give me the 2 times row 1 will give me the second row. Okay, so if I do the rank of matrix A, I should get the number as 2. Now this rank of matrix A is less than your number of unknowns n, right? So that means if you want to solve this problem, you will have infinitely many solutions. Your system is underdetermined, right? Let's say my matrix B is 0 0 0. Now to solve this, you have lean solve command, right? To solve the system of equation, you have lean solve command. I am as of now showing you. We will again come to this part also. So if you do, sorry, I have to create a column matrix. You can see you are getting not a number because your system is underdetermined. Thus you will have so many solutions. Lean solve. Just a minute. You can also check the error somewhere. I forgot it how to do it. Lean solve. Maybe maybe later we can check. Yeah, let it go. I will come to this aspect again, that how we will get the infinitely many solution or not, right? Then third case we have, now we have this matrix 1 1 1 minus 1 2 1. So let's see if my A is equal to 1 1 1 minus 1 and 2 1. This is my matrix A. I'm finding its rank, so rank is 2, right? Now here also, if I define the B matrix and try to solve it, I will get 1 and 2, right? I have 2 unknowns, 3 equations, 2 unknowns. Oh, it won't do it because it's by default it's showing the condition that your system is overdetermined. Since system is overdetermined, I have more equations than the unknown. It's not doing its calculation, right? That's why it's not working. So this also shows that my system is over determined, right? Now then you have third example, matrix A is 1 2 3 4 and then 5 6 7 8, right? So is equal to rank of A is 2. Now I'm looking at rank and commenting based on my thing only, but let's say you can also create a function file or a script file to see what is the rank, right? So for that, like here, what I will do is I will create, let me copy paste this and then explain it. Let's say you have this matrix 1 2 3 4, your A matrix, and this is your B matrix, right? So first you look at the rank of matrix A through rank A. You create an augmented matrix AB, you find its rank. Now you compare if their rank is equal or not. If their rank is equal, that means you will have a solution. Now if their rank is equal to number of unknowns, which will be determined by number of columns, so this size of A2, what does it give? It will give you the number of columns, and that number of columns will correspond to n, which is your number of unknowns, right? So if both the ranks are equal and they are equal to n, then I will have a unique solution. If both the ranks are equal but they are less than n, then I will have infinitely many solutions. So first condition, first master if condition is that whether the both ranks is equal or not. If it's equal, then I will have a unique solution or infinite solution, right? So how to determine that? Then I compare what is this rank. Is that rank is equal to number of unknowns? If yes, then you display I have a unique solution. If not, then you display we have infinite solution. So this is one part. If both the ranks are not equal, then that means I have there is no solution. Okay. So if you will run it for this example and see, if you will run it and see, this is how what you are getting. Rank of matrix A is 2, A augmented B is also 2. That means unique solution exists for that system. Consider this example, this only. So this matrix we saw, now the parameter A, B, I have changed it. So let's try to see what happens now. So in this case, my rank of matrix is 2, augmented matrix is 2, both are equal, so I will have you have to first check whether that you have solution or not. So whenever you have been given the system of equations, what you do is first calculate their rank of your coefficient, rank of your augmented matrix A and B, and based on that you first determine whether you will get a unique solution or infinite solution, and then proceed ahead, right? So let's say you have been given some problem and you start solving it, but at the end you realize, okay, there does not exist any solution, or you are getting an error. What could be the reason? The reason could be the basic part, that you have not checked whether you have unique solution, infinite solution, or no solution. Okay, so this was one aspect. Now let's look at some of the numerical methods to solve this system of equation. So I'm not sure how many of you have done numerical methods course in your BTech or current, or will be doing, right? So when you will come, you might come across this Gauss elimination, LU decomposition, or Jacobi iteration methods. So these are the methods to solve simultaneous linear equations, right? Of which we will first look at the basic method, Gauss elimination method. Other methods are kind of built up to this method to make it much faster, or to give a better efficiency, right? So in this Gauss elimination method, what you do is you first transform your matrix, your augmented matrix, into upper triangular form, and then you do back substitution to find the what will be the variables value, right? So for that I have included this reference to show you one example. So in this example, I would recommend you to go through this just to understand the Gauss elimination method. If you already know it, then fine. If not, then please go through it once, and then you will get the gist of the method, right? So what you do is here you transform your system into upper triangular matrix through a series of row operation. Okay, so you only do the row operation, and then once you have the upper triangular matrix, you back calculate it, you backtrack the system equations, and then find the variable data, right? So this is how it follows. So let's say you have this two equations and two unknown system, right? So now my A matrix becomes 2 3 4 1, my B matrix is 8 and 10, right? So augmented matrix, you can write it in this fashion. Now I want to convert this matrix into upper triangular form. So for that, if I want to create it upper triangular form, that means all the elements below the diagonal, so all the elements below the 2 1 should be the 0. Right now it's a smaller matrix, so I only have to do eliminate this element number 4, right? So for that I have to do row operation, right? So if you multiply the first row with 2 and then subtract it from the second row, you will get the this element will become 0, and you will get the upper triangular matrix, right? And correspondingly other variables also will change. So 1 minus 6, that gives you minus 5, and 10 minus 16 gives you minus 6, right? Now you have this. In the second step you back calculate it, right? So what our equation was, Ax equal to B. So this is my reduced the new transformed matrix A, transformed matrix B. If I use it now in the Ax equal to B form, and then expand it, so what I will get is minus 5y is equal to minus 6. You get the y value, then you put it into the first equation. So 2 times x1 plus 3 times y, 2 times x plus 3 times y is equal to 8. You already know the value of y, then you can compute the value of x. So this is for 2 equations. If you have a 3 equations, then you will have this 3 by 4 matrix, 3 by 4 augmented matrix, then you solve it, right? So for a smaller element, it's fine, you can do it by hand, right? So here is, they have given the example of 3 equations, 3 unknown system. But once you have more number of unknowns and equation, then it's become difficult to find this, right? So for that you have to rely on some of the coding part, which we will do. So our next problem is to create a Matlab function file which finds the solution of system of equation using Gauss elimination method. We have been given user input A and B, and then we have to compare our result with the inbuilt Matlab solvers, right? So first let's try to code this Gauss elimination method, and then we will compare what result we are getting from this method to the inbuilt Matlab solvers we have, right? Okay, we have. Just a minute. So we have been asked to create a function file, right? So what I will do, create a function which gives the solution. We will name it as Gauss elimination function. Now for this function, what we need coefficient matrix, right? As well as we need the vector b. Vector b is your constant vector, okay? And based on that, we will find the value of your variables, okay, x. So this will be my function. Now let's provide the command which says if you want to find the help for this command, provide the coefficient matrix A and constant vector B, right? So once you have this, what you will do, you first find what are the number of rows and columns for the matrix. So I do row. You will create a matrix C first, which is an augmented matrix A comma B, right? Sorry. You find the number of row and column for this matrix through size function. So when I do size of a matrix, it provides me its row and column, okay? So that will be stored here in row and column part. Now what we have to do here, that if you will see this example, what we did was we took the first row, and based on the first row we try to eliminate the second row lower triangular part, right? Okay, when you have multiple such equations, what we can do is we can follow the simple basic strategy. Since I want to create a universal function which works for every system, so for that I know that I have to multiply R2 with -2, okay? I have to multiply R1 with -2 and then add it to R2, then I will get the transform part. But every time you cannot check it, okay? So you have to generalize it. What generalization is that? So if I want to eliminate element 4 here with respect to element number 2, which is the first element, first row first column element, what I am doing is I take the ratio 4 by 2 is 2, right? That ratio I multiply with the first column and first row, and then I'm subtracting it with the second row. In that case I am getting the 0. So all the time I have to find a one multiplier. Let's say you have further row below. Once you have zero down the element here, now you want to further zero down the element, then you can utilize again the same strategy of R2, and then try to find the ratio and try to create the lower triangular matrix with a 0 element, okay? So for that, so basically what we want to do is we want to generalize it. So every time we will find what is that multiplier. To find that, what I will do, I will create one I loop which starts with 1, goes to row -1, within which I will have another loop which start with I plus 1 to all row, okay? Now once I have this 2 loop, what we will do, first I will find the multiplier. Okay, I'm calling it as a multiplier. What this multiplier will be, that I have this matrix C, augmented matrix. I extract out its element. What this element will be, that will be J comma, let's column J comma 1 minus, sorry, divided by C. This is capital C, right? Capital C, I comma 1. Okay, so this is the multiplier. So if you will try to put it with this context, what I have done is 2 comma 1 and 1 comma 1. I am finding this ratio. Okay, so this is the multiplier. Once I know the multiplier, what I do, I transform the other row, which is the second row, J row, all the elements, by C J row, all the elements, minus multiplier C I comma J. Okay, so this deals with the first part, right? Now at the end, as of now, let's just see whether this thing works or not. So I'm creating, I will store this augmented matrix as C and try to see whether our method is working or not, as whatever I have done as of now is working or not, right? So I call the equation, which is, call the function Gauss elimination. So you have to provide the matrix first, right? My matrix is two one one minus 3 minus 1 2 minus 3 minus 1 2, so 2 1 minus 1, 2 1 2 minus 2 1 2. Okay, this is correct. Then B is 8 minus 11 minus 3. B equals 8 minus 11 minus 3. Right. Now we call Gauss elimination. Unrecognized. It should be capital C. So here what you got is 211, not a number. So that is some error. What error this is? I'm doing I is equal to rho minus 1, J is equal to I plus 1 to rho. So first is minimized, then second 2, and it goes to 3. 3 by 1. Let me just quickly see the previous part. I think I have made some mistake. UJ comma I. Second row, first column. Oh yeah. So this is actually, it should be J comma I and I comma I. Now it should work. And then you have Cj all multiply J all. Okay. Now let's write again. this folder. Right. So actually what we did was, you have A augmented B. This is your A augmented B matrix, right? So first, when I want to convert this matrix into the upper triangular matrix, that means all the element below the diagonal, this -3, -2 and 1 has to become 0, right? So for that what I do, I take the element 2, I take the ratio of -3/2, okay, and then that will be -1.5. I multiply row 1 with that and add into row 2. So this element will become 0. I will have some value, I will have some modified value here, right? So this is one part. Now I have made this -3 0. Now how my code works is, I'm still on the outer loop, is still on row 1, but inner loop has gone to row 2, and now it is going to row 3. It is going to row 3, it's seeing -2. It will element this it will transform this -2 to 0. So -2/2 -1, you multiply you multiply row 1 with -1 and add it, so this will become 0. So you have first converted -3 to 0, -2 to 0. Now you move forward with this part, okay? So that's why you have this. Now your I will change to second, number 2. So you will take this element, with this element of -1, you try to make it this 0, okay? So this is how your matrix is updating. What you can do is, I can display C here in between to show how this exact change is happening. So this is how this change is happening. You have first made this 2 element 0, then you are making this element 0, okay? So this is how you are working. Now you have this transformed augmented matrix, right? So if I want to solve it, then if I convert it into Ax equal to B equation, right? So my x3 minus x3 is equal to 1. So your x3 value is -1. Then you have half a times point x2 plus half a times x3 is equal to 1. You already know the value of x3. You can find the value of x2. Then you have 2 times x1 plus x2 minus x3 is equal to 8. You know the value of x3, x2. You can back calculate the x1 value. So once I have this augmented matrix ready, I have to go backwards and compute the elements, right? So now we will do that. For that, maybe you can put this here. To observe the transformation. Okay. Now, once you have found out this, back calculating to find the value of x, okay? So first thing first, whatever your size of your matrix is, right here, be it be 2 cross 2, 3 cross 3, 4 cross 4 or 5 cross 5, your last element of your row will correspond to, so your last element of a transformed matrix A will corresponds to the transformed B matrix, okay? So from that you will get the final element value, right? So I can write x, and let me create first x matrix, which is zeros, and it is equivalent to whatever column -1, okay? Yeah. So this is your zeros matrix. Now the last element of your matrix is nothing but, if I have the augmented matrix C, my row column -1 divided by C, sorry, row and column minus 1. So this will be my last element. Are you able to understand it? See, what I am doing, I am accessing the augmented matrix final element, which is row column, right? So C row column will correspond to third row, and 4 column, that will correspond to 1, which is final row column minus 1. So I am dividing it by this element. So this will give me the end value, x3 value. Okay. Now for the other elements I have to back calculate it. So what I will do, I will run another for loop which will go to row minus 1. I am moving in negative direction, so I have to back calculate it, right? So this is the third row. Now I will move to second row and then first row. That's why this loop will start from row minus 1 and I am moving till in the negative direction till I reach the value of 1. Now each time I will compute the element which is I, right? So right now we have computed third element. To compute the second element, what I have to do, I know again this part, that you have to access this C row end column. You have to subtract all the other elements and divide it by the coefficient, right? So here actually I'm not showing you the math part. No, you have left. Okay. So I'm not showing you the math part, but if you will try to simplify it in the equation form and write it on the pen and paper, you will find the correlation. Okay. First try and do that, and then you will understand the general logic what I am following here. Still, if you still have a doubt, then try to contact me. So some of the maths part I am leaving, else what will happen, that we will be stuck at the one same concept for a much longer time, which I don't want. Okay. So here again, let me just quickly refer to the previous equation. You have this row column minus 1. Yeah. So basically I column, you access this part. Okay. Let me modify it and I will tell you what we are doing here. Okay, so here we have come to the second row. In the second row, if I have to find x2, what will be x2? X2 will be this b2 minus what is 0.5 times x3 divided by 0.5. Okay, so same thing, if you apply it into the matrix form, I am doing Ci column, which is 2 comma 4. So your final element b2 minus Ci. Now all the elements which will follow from I plus 1 to column minus 1, okay, that into the x value from I plus 1 to column minus 1 divided by the ith coefficient, okay, Cii, that I am doing, and I am getting this value. Now I know this equation seems complicated, but my suggestion is you try to generalize this equation. Then only you will be able to understand it, what this logic is. And once you do that, now if I want to find the solution, this is how my solution will look like. Too many input arguments. Why? Not here. Yeah, here. I'm getting some error, which is incorrect dimension for matrix multiplication. It should be dot product. Let's see. some error, just give me a minute to figure it out. Cth column, next is I plus 1 to column minus 1. Yeah, it should work. Just give me a minute. What it is different here? Oh, yeah. Now let's see. Yeah, this is how it works. Right? So you had A, we have been given B, and when I do Gauss elimination and try to back calculate it, this is how I will get my solution. Okay, so this is what Gauss elimination method is doing right now. There was this just change in this zero matrix. So initially it was creating matrix, I had to create a vector, right? So this was the only change, else everything is same. Alright, so this is how you can generalize the method and find the solution of your system of equations through a Gauss elimination method. Now you don't have to code this always. For Matlab, Matlab provides you the various tools to find the solution of two linear system of equations. So you have this line solve, LU composition, you have backslash operator, and then you can also use the inverse of matrix. Okay, now inverse of matrix is not recommended, but we will also see, we will see all the four methods and how to find the solutions with that. So first you have this backslash operator, right? If you will see help slash d. If you recall the first class, right, a slash b is nothing but b by a, right? It's a reverse way of writing it. For the matrices, it's useful. So when I do a slash b, what it does is it does a inverse into b and then gives you the result, right? So previously our result was 2 3 minus 1 from our method, and you can see when I do inverse into b, that also gives me the same value. You can use inverse into b, this will also give you the same data. Then we have lean solve command. Lean solve command we have previously used in the initial lecture, right? So this solves the system of linear equations. If you will do help lean solve, now it uses LU factorization method, which is slightly different from the Gauss elimination method. So in Gauss elimination method, what we did, we tried to convert our matrix into upper triangular matrix, okay, by removing the by making all the lower triangular matrix element 0. In the LU factorization method, your matrix A is converted into two parts. One is composed of upper triangular matrix, another which is composed of the lower triangular matrix, right? And with the help of this L and U, so that's why lower and upper triangular matrix, that's why name comes as LU factorization. You can backtrack and calculate the your coefficient, your variables, okay. Then apart from that, you have LU separately also. So LU again stands for the your lower and upper factorization method. When you are using the lean solve method, actually what it does, it sometimes uses some other partial pivoting methods also. So see, it uses LU factorization with partial pivoting when A is square, or QR factorization with the column pivoting otherwise. So depending upon what kind of matrix you put, A and B, this lean solve will determine what method to use on its own. While if you want to specifically work with the LU method, then you can use help this LU part, right? So if you will do LU, you will get the lower and combination of, so you have to provide it in this fashion: LU L comma U is equal to LU E. So it has converted your matrix into lower and upper triangular matrix, right? Now with the help of this upper triangular matrix, if you try to back calculate the previous part, you will be able to get the your solution. Okay, so this is how it works. Now just one more thing here, documentation. Lower upper yeah. So in the LU method, these are your this is how you can solve it. So once you have upper and lower triangular matrix, you can use that to find your solution. So let's say you have to use this LUP is equal to LUA. So here you will get three matrices. Now here P, you have description for everything. Your P is your factorization vector such that your P into A becomes LU, right? L into U. Then you can use the following command. And then you will get the solution. So just read about this method more, slightly more in detail. So then you will be able to understand what exactly these methods are doing. Right? So you have this option. Either you can do it by your own code, or you can rely on such methods. Right? Now depending upon your need, you may decide what you want to do. Sometimes you have to do some modification in your code. Then in that case you can decide to do your own code, like what we did in Gauss elimination method, or else by default options are also okay to work with. Okay, so this was one aspect, that we understand what are this linear system of equations, how to determine whether its solution exists or not, right? So here for that we created this type of solution equation, right? So let's say we take this our own data right now that we have selected. Here I didn't check whether I have unique solution or not, but I can do it. 2 1 minus 1. So let's say your A is 2 1 minus 1 minus 3 minus 1 minus 3 minus 1 2 2 minus 2 1 2, and your B is 8 minus 11 minus 3. 8 minus 11 minus 3, and then this. So you are seeing your rank of matrix is 3, rank of augmented matrix is 3, so you will have a unique solution. Actually we should check this first and then try to solve it. We didn't do it, but this is how you can do it. Even in your Gauss elimination method, what you do is, I recommended you add this check part first, okay, whether to check the rank of matrix and then determine whether you will have a solution or not. You also try to do some example where you will have infinite solutions and then see whether Gauss elimination method is able to give you that data or not. Some related command to this part is, there is row REIF, help. So this Gauss elimination method, the conversion of our matrix to the upper triangular matrix is row echelon form. If you recall your numerical method classes, there are inbuilt command also to convert this. So this ref command is also useful to convert your matrix into reduced form. Right? So here actually it converts it into the diagonal matrix form. That's why you are getting this result. And see, you can directly now check your x3 is minus 1, x2 is 3, x1 is 2, which was our result, right? So there are in between command also to do this row operations. Maybe it might be useful to you in some cases. I just wanted to mention this. So what we did, we understand the conditioning of the finding the solution. We saw this one method, Gauss elimination method, we coded it, and then we verified our result with the inbuilt command. So these are working. Now let's look at some actual example. So we will do this multi-component distillation problem. Here what we have been given is, we have a separation system which separates toluene, styrene, xylene and benzene mixture. So you have this 4 component, 1, 2, 3, 4 into 4 different streams, right? Now what you have been given is feed composition is given and feed flow rate is given. You have product composition also, both the distillate and the bottom product has been given. What has been asked to us is that the process was running in a steady state. However, due to the failure of master feed pump, the feed rate has dropped from 70 mole per minute to 20 mole per minute. In the step of 5 mole per minute, okay, the molar composition of distillate and bottom remains same. So the mole fractions that we have been given to us remain same. So assume the no transit in the system and equilibrium is maintained during this change. Report how the production rate of each product gets affected. So we have to find this D1, B1, D2, B2 value when we have a steady state, and when this unsteady state is introduced, when our flow goes from 70 to 20, what will be the change in the product flow rate, right? Now it's a distillation column system. So first what we will do our mass balance or mole balance in this case, and we will check what equations we have, right? So here for the distillation column, distillation problem. Okay, so for distillation, what are system of mass or mole balance equations. So your mass or mole balance equation will be, one, you have overall balance, right, which is your feed. Here my total flow rate F will be D is further divided into D1 and B1, B is further divided into D2, B2. Okay, since it's a unit operation, there are no reaction happening, so at the end overall mole will still remain same. So I can write F1 is equal to D1 plus D2 plus B1 plus B2, right? This is my one equation which follows. Then you have component balance. So component balance is written as I have mole fraction xi xif into f is equal to, so I know the mole fraction of component in the feed, so that mole fraction into total flow rate will be equivalent to mole fraction of that component in D1 plus mole fraction of that component into B1 plus mole fraction into D2 and B2, right? So your simple mass balance. So then I will have xi into D1 into my flow rate in D1 plus xi D2 into flow rate, let's say I write it B1 first here, B1 into flow rate B1, just for the consistency, nothing else, xi D2 into D2 plus xi B2 into B2. Okay, B1. So this is how my equations will look like. Now here, how many variables I have? I don't know D1, B1, D2, B2. So we have 4 variables, and correspondingly you have 4 component balance and 1 overall mass balance, right? Out of which if you will realize like you can get rid of one equation since they are interconnected, right? So if you know the composition, like if you know the flow rate of 3, if you know the data of 3, you will find the value of 1, right? So you don't need all 5 equations. We have 4 component, thus we can use 4 equations with 4 unknowns. What are your unknowns? So unknown is your flow rates, right? D1, B1, D2, B2. Okay. So this is nothing but what we are doing here. We are eliminating our extra equations, extra linearly extra equations. Okay. So just to reduce our computational cost, you can also include the 5 equations, right? In that case, what will happen that in your Gauss elimination method, some matrices will be, some row will be eliminated, and then you will at the end get the same results, right? Distillation. Okay, now once we are done with this, let's try to code it. So we will solve Ax equal to B, system of equation. Now here your x will become your unknowns, so which is D1, B1, D2, B2, right? Your A is your coefficient matrix, so A is coefficient coefficient, or here it's mole fraction matrix for this case only, and your B is constant matrix. So since I know the F already, what I will do, we will use this component balance equations to find the to create the A. So my matrix A becomes, so xi for D1, B1, D2, B2, I have to put that. So if you will see here, for benzene, so benzene is labeled as 1, so I have to use 0.35, 0.16, 0.21 and 0.01. Point 0.35, 0.16, 0.21 and 0.01. Then 35, 16, 21 and 0.01. Then for x2 you have 0.54, 0.42, 0.54, 0.42, again 0.54 and 0.1. Then your x3 is 0.04, 0.24, 0.1, 0.04, 0.24, 0.1, 0.04, 0.24, 0.1 and 0.65. 0.65. And last you have 0.07, 0.18, 0.15, 0.24, 0.15, 0.24. Right? So this becomes my A matrix. My B so here we have been actually asked to see the change with respect to flow rate, right? Your B matrix will be this made of this component xif into f. Now my f is varying, and my f is varying with time. So not with time, with the condition that I have been given. So what I will do, I will create a f matrix. F is equal to, my flow rate is varying from 70, it's going with a step of -5 till 20. Okay, so this is my f. My B matrix is nothing but, so as of now I am commenting this when we have to do, no, yeah, let's keep it, right? Now my B matrix should be into F. My composition is still remaining same, so here this data will be valid 0.2, 0.4, 25 and 15. 0.2, 0.4. Just give me a minute. I think it's okay. Now what I will do, since it's a loop, first let's look at what happens at the initial steady state condition, and then we will worry about the variation, right? So as of now I have created B matrix in this fashion, that I have component, actually this will be this is a column vector, right? So this is how create into F. So xif into f will give me this data. Okay, so this is my B matrix. Now my solution x is equal to, I can use lim solve a comma b, right, and then say display the corresponding product stream flow rate is this x. Okay, we will modify this result further, but as of now let's work with this and see what we are getting. So this is our solution. So corresponding product streams flow rate is, your D1 is 26, your B1 is 17, your D2 is 8.7 and your B2 is 17.5. Let me do summation of this result x. So this comes to 17, right? So overall total molar flow rate is same. Okay, now we were discussing whether to include this overall mass balance term or not. So let's say if I include this, in that case what will be my coefficient for this 111, right? 1 1 1 1, and here also it will become 1. Okay, and then let's run it. So still my answer is same. Okay, but here my rank of A in this case is 4. And rank of A augmented B is also 4, and my number of unknowns are also 4, right? So I will have a unique solution here. Okay, so then since I can work with 4 equation, why to add an extra equation to increase the computational power? Now here for this small part you don't understand it, like you get the result instantly, but when you have so many equations, then your computational efficiency will be needed, right? In such cases you try to remove the elements which are repeating. Okay, so this was the first part, like we understood this. So if the process is working, it's operating at a steady state, so when the flow rate is 70 mole per minute, this will be the product flow rate. Now due to some power failure or pump failure, the flow rate has dropped from 70 to 20 with a step of -5, right, with a decrease of 5 mole per minute. In that case we have to find how this solution will change. So for that what I am doing is, now I will take this, my flow rate is varying from 70 to 20 mole per minute, decrease in the flow rates. Okay, now since I have multiple f value, multiple f data, so every time my B matrix will vary, right, and accordingly my solution will vary. So I cannot keep it as a one data. I have to compute x value and B value at every flow rate and then store it somewhere. So for that what we will do, we will run one for loop. This for loop will run through the length of my f matrix. So how many, whatever data points we have between 70 to 20, based on that here f of I, right? So let's say I start with 70, my B value will consider 70, B value will be based on the 70 flow rate. Then next step, I is equal to 2, my flow rate will be 65. Okay, so for that uh, my B matrix will be based on the value of F2, which is 65. Okay, here I is equal to 1. Yeah. Now lean solve. Okay. But this is still not storing data in the uh, complete matrix. It's computing and then forgetting. I can put here display. I can do this display, or rather than display, I think fprintf will be a good option here. Fprintf, which says flow rate percentage d comma fi, right? Then here slash n also, I want to start a new line. Corresponding flow rates are slash n. Fprintf d1 slash tab percentage f comma x1, right? Here also, like my x will go from x has a length of 1 to 4, but let's say again I want to create a manual code where I don't have to worry about this thing. Like I don't want to manually put 1 2 3 4. So rather than, I will create again a for loop which will print this f comma xi. Still there will be some manual input needed because d1 d2. Let's say we do this. I'm just trying to represent it in a better form, more like a tabular form. So let's say I write it d1 tab v1 tab d2 slash d d2. d1 b1 d2 b2, and this will print fprintf %f corresponding values of xi and end it, right? Fprintf xi. Oh, again my mistake, it should be xj here. Start with a clear thing, clear all CLC. Yeah. So this is how it will vary. For flow rate 70, These are your product flow rates. For flow rate 60, this will how it will vary. Still not a nicer way. Let me change it again. Just a slightly new line. Yeah, this is better, right? So for 70 flow rate, you will have this data for 65, 60, and this is how you are getting. But this is a tabular representation. You can store this data into some text file, like what we learned in the last time, right? So in the fprintf, you can use the file option, which will print your data into that particular file. Okay, but I also wanted to see a visual representation of how exactly it will look like. So for that, what I have to do is I have to store this data somewhere, right? So for storing, what I will do is I will create stream data matrix. Now this matrix, so my x column, I have four variables, right? This four variable changes for different value of f. So I will create one zero matrix whose column will row will correspond to the f, and column will correspond to length of x. Again, x is not defined here. Let's define x also. X is equal to length of my beam. No, 1 2 sorry, x can be the zeros, then I want to have size a comma 2 comma 1. So what this will do is it will create a column matrix, correct? Yeah, so we want this length of x, and this will create corresponding. So then we can use this value to create a plot, right? I do this stream data. Once you have computed it, you can put this stream data x all. Let's see my stream data. Yeah, so this is how this stream data looks like. Yeah, this is perfect. Now we can use the stream data to create a plot. To track the variation in a flow rate. What will be plotting the variation? So for that, create a plot. Your x-axis will be change in the flow rate, right, from 70 to 20. Your y-axis will be stream data, my all rows first column. This will correspond to my D1. Okay, so I'm not let's me put a label. No, label we can put it at the end, right? So this is for D1, plot for D for change in D1, then you do hold on. Second column will be your D1, third column is your D2, and finally your fourth column is D4. Sorry, B2, not D4, B2. You can do X label, which will be the feed flow rate, this much mole per minute. You have Y label as product stream flow rate, this much mole per minute. Now X label, Y label, you can provide the title to the graph which says change in a flow rate. Product flow rate minor yeah, I think I forgot the command. Okay, then you can do further customization. Let's keep it simple here. Now just add the label part. So for the label, you can do this label. My first label is D1, then I have D1, D2, D2. Okay, let's run this. We have got the plot, but some error. What is this error? Unrecognized. Oh, it's legend. Sorry. And this is how our plot looks like. You have 1, 2, D1, B1. Is there some overlap? Stream data. Yeah. So actually B1 and B2 are identical to each other. That's why there is an overlap between them. Okay. Since it's a reference example, I'm not sure such thing could happen, right? But you can see this is how the variation will look like. From going from 70 feed flow rate to 20, this is how your product's flow rate will change, right? So this is what was asked, and we computed it. We used system of linear equations to define our system, right? So here we have been given like the way sir follows it. First you understand your system. We had multi-component distillation column. We defined it through a series of mass balance equation. That is your second step part. Third step is to solve equations. So we know that it's a linear algebraic equation, simultaneous equations, right? So that was the third part. Fourth part is identifying the methods to solve it. That we know that there are inbuilt tools. So we used linsolve command in the Matlab to solve this system of equation. And fifth is to analyze this, right? So this is how we followed it and reached to the conclusion. Now, as I said, I will touch to this part which will help you to better code SIRS example also. So in the SIRS example, the initial part is very clear, like when you are doing this, you are providing matrix A, your matrix B here will be nothing but your right hand side of your equations, right? So when you write it very neatly, it will be your mole fractions into F. Okay, so similar to in our case here, RB was in feed mole fraction into feed flow rate data, right? So same way the equation sir has written it will follow the same pattern, right? So here you have multiple mole fractions. Your unknowns is nothing but your stream data from so you have this 5 and 4 total 9 stream. So your x is 9, x is a 9 cross 1 matrix, right? 1 2 3 4 5 6 7 8 9, and your B will be m cross 1 matrix. So so it will correspond to all these equations. So first is this 1 and 2 and 3 are total mass balance equation, right? And then these are your component equation. So each will correspond to one composition that you can write it. Okay. Then the second important part was to read the data. Okay, so for reading, you can use some inbuilt packages in Matlab to take or extract the data from some user text file. This is useful for the automation part, right? So here in this example, what we did is we added the matrix A and B data by hand. Now it's not always possible to manually update our code. So creating more user friendly code is where user has to give minimum changes or provide minimum changes to your code. So basically user provides specific information in some format, and then you calculate the data based on that. So for such cases it's better to create one format where user provides this input. So in this example, user is providing input in .txt form, and from that you are taking all the information, creating your equations and solving it, right? So this was the basic idea here. Now here the text file that sir has input, it corresponds to this fashion, right? So your first row contains all the variable name, second row contains the variable data, and then you are solving it. So what I will do here, let's try to see what exactly this command does. Detect import option. So when you search help detect import options, so you see I'm getting very long description for this detect import option. Creates import option based on the content of file. So it tries to automatically read the file, and based on its content it's try to create what kind of data it will have, right? So then again you have specific information provided. Look, so when you give detects, locates a table given in the input parameters. Many parameters can affect how the other parameters are detected in file. For all file types, variable type is determined. For text and spreadsheet file, different options can be considered. So you can provide what are the delimiters to differentiate text, differentiate the spacing between the variables and stuff, right? So you have so much options. Now obviously depending upon your requirement, you have to figure out what kind of option to use. You can see the detailed documentation on the Matlab website also. It's not working. So here some examples are also given, right? Now what will happen when you use this detect import option file? Okay, so let's try to understand by considering very basic example. So I am currently in this folder. So in this folder what I will do is I will create a text file. Okay. Let's call it as test file, test.txt. Here I will introduce variable 1, variable 2, variable 3. Sorry, spelling is wrong. Let's put some value. Let's set some mole fraction. Okay. 0.6. I'm just saving it. First I'm doing nothing. I'm just trying to understand what this detect import option does. Import option, and I'm just putting test.txt and see what it does. So it has read through this file and created multiple things, out of which what I am able to understand is it has created some variable names, variable 1, 2, variable 4, right? It's 4, yeah, 1, 2 and variable 4. There are some variable options. If you will click here, it will show you the further data. Just a minute. Slowing down. Okay. Let's leave it at this. Here, what second option you have, once you read the file, so let's say file, so one variable is created which reads the file through detect import option. Then variable description lines are given, that we have 2 lines, and then read table is created, right? So let me do that and see how it works. Oh, Matlab has crashed. Is recording working? Yeah. This is also. So let's create file is equal to detect import option, and then my test.txt file, okay, has been created. Then next option was to try out this read table. So what I will do, t is equal to read table. I'm just putting the file file name here. Sorry, test.txt file. So it's creating this, so it's giving me this way. So it has created one table. We can view this table also. Not here. Yeah. I want to open this table. Okay, I think my system is overheating, that's why it's not working smoothly. It should show the table. Maybe you can click here and there and figure it out. So it has created the table. Okay, right now I'm trying to understand this command. So let's say if I don't provide the file option and see what happens. Still it has created the read table data. So this file option or this variable description line, it's not necessary to provide, right? So you can try and see and play with the commands also, what is required and what is not required, right? Now with this t, once my system my table t is defined, what sir is doing, he's calling them through this data, that t dot weight CO2 crude. Now here I don't know what to call it, so if I type t dot and I press a tab, if you press a tab you will get various options. So you have variable option, variable 1 option. So if I type t dot variables and select it, I am getting all the variables data, 0.1, 0.6, 0.4. If I do t variable 1 only, so I am getting variable 1 data. Variable 4, I am getting variable 4 data. If I do 3, I haven't defined variable 3, then I should get some error, right? Yeah, it has not recognized any variable since we don't have any variable. So this is how you can access the data from this table. Now let's modify it. In this case, what we had done was we followed the SIR method, that we have first line to define the variable, second line to give the variable input. Let's say I have a fourth and fifth line also. Then will I be able to read it? So if you do that, I read the file, read the table. So you can see it has still read through the file, created variable 1, but all the elements below it are the part of that variable 1. Variable 2 has 3 elements. Similarly, variable 4 has 3 elements. So when I type t dot variable 1, I will get this data. When I type t dot variable not 3, variable 4, then I will get this data. Okay. So you can read multiple number of lines in a file. You can create multi-variable tables also. It doesn't have to be one line, one variable. So here my point is, whenever you encounter such new commands, right? So basically for file reading, I haven't used this command previously. So I'm trying to understand what this command is doing. What are the various options? So I generally do read CSV file, which I import directly through other commands. So now to understand this property, what you have to do is you have to go through the manuals like we did here for the detect import options. You see what are other parameters you have to provide, what things you can do, and how you can manipulate this variable or command to your advantage, right? So that's the basic idea. When you are working with any new programming language, try to explore it to understand how exactly to use this command, right? Now once we have this variable matrix ready, what we are doing is we are creating symbols. So let's say here I have three equations, right? Sorry, total 9 variables. uh, Variable 1 has 3 data, variable 2 and 3 has 3, and variable 4 has 3. I create 3 symbols, x1, x2 and x3, and I want to create the equations, 3 equations based on this. So for that you do equation. Now t dot variable 1, you have row option also. Let's check out what row option does. T dot row, it gives you the 0 data. Why? Oh, I'm sorry, my Matlab is crashing, probably because of overheating or overuse. Just a minute. I hope recording is working. Yeah, this is working fine. Let me close this. Any of this is. Hopefully this. Okay. Let's say my equation 1 is based on combination of this variable. So I want to access t variable 1 into first let me look how I can use t variable 1. If I do this, indice 1, indice 2, this. So maybe what I can do is to create my equation. Equation 1 is t dot variable 1, its first part, into x1 plus t dot variable 2, its second part, into x2 plus t dot variable 4, sorry, first part, I'm considering first row right now. So first into x3 equal 0. So this is my first equation. It has created this equation. Then my equation 2 can be this is my equation 2. Let's create third equation, equation 3. So I have created 3 equations, right? Now, so this is how you can take a user input, convert that user input into system of equation. What sir has done here, that you are taking input from .txt file. So basically you are taking a composition. So you can think of this table as a composition table. You have 3 variables, x1, x2, x3. you are creating an equations, right? So same thing has been done here. You have created these equations. Now you are using this equation to matrix option to convert your equation into matrix A and B, and then you are using it to find the solution, right? So for that, let's say if I do A is equal to, let's understand first what is equation. What happened? Equations 2, no completion found. It's not fine. Equations 2 matrix. Oh, it's equations. There is a plural in that, right? So you have one example also, like let's say you have 3 equations, so you can use it in this fashion to create 2 matrices. So let me do that. First I will do equations 2 matrix for my eqn1 comma eqn2 comma eqn3. My variables are x1, x2, x3 and z. Okay, so this is how it is finding my coefficient matrix. I can do A comma B also, then it will give me coefficient matrix as well as the constant matrix, right? And then A slash B should give you the answer. So currently answer is 0 because it's a random, I have taken the random input, right? But same way you can do, you can solve the Searle's problem. So you are using equation to matrix option to convert this equation that you have created into 2 matrices and then find its solution, right? So this is how you proceed ahead with Searle's problem. I hope this helps you to identify the approach to the way to solve Searle's example, right? If you still have any doubt, then you can let me know maybe in the next lecture, at the start of next lecture, or you can try to communicate me via email or email. If you have doubt, then only I will proceed with the detailed explanation, else I will follow the next class content and next week content and try to explain you things related to that, right? So do let me know what you think about it. If you have any issue, we will try to solve it, right? Else I will proceed with the way I have planned further content. Thank you.